Hi everyone and welcome back to the Multiverse of 100 plus data science project series. In this video, I am going to building here a machine learning problem based on loan approval predictions. Here we're going to using the Python and FastAPI. So without any further ado, I'm going to start the tutorial right now. In order to building our machine learning model, we're going to use the dataset from the Kaggle that's called a loan status predictions. And that's our dataset. So if you go down, you can get here one CSV file, comma, separated file. Just you need to go on that and create one account of that, and after that just simply click on download. Now we're going to using this CSV file and try to building our machine learning model and also test it out in the FastAPI. We're going to building the API using FastAPI Python library. So let's go on the Jupyter notebook. First, I'm going to importing here all of the important library which one is required to building our machine learning model. So first thing first, I'm going to importing here the pandas. So let's say pandas as pd. So using pandas, you can load your raw data or the CSV data from your folder or directory. Then I'm going to importing here numpy as np. Let's import numpy as np. So using numpy, you can do some other types of calculations or scientific calculations using numpy. Then I'm going to import from sklearn, also called the scikit-learn, from sklearn dot model selection, model underscore selection. See, I got so many error when I'm actually typing this model selections. So you can also using here one shortcut. Let's say sklearn.model. Then you can press the tab key from your keyboard. Okay, so it will give you the auto suggestion. You can see it gave me the auto suggestions. So I can select the uh, model selections. So it will actually boost your speed of the writing the codes. Okay, so now I'm going to importing here the train, test, and split. See again, tab. Okay, again I press the tab, it will auto complete this one. How cool is it? Okay, train, test, split. Then I'm going to importing here the cross. Okay, so cross bell score. Okay, it's nothing but for the cross validations. Then I'm going to importing here the randomized cb. So randomized cb actually used to hyper parameter tuning of your machine learning model. So there are two types of cbs are actually available. One is called the grid size cb, which can go just like the sequentially. A randomized cb is nothing but taking the some random data point and try to do the hyper parameter tunings. Cool. So we're going to using this one. And also from sklearn dot linear model, we are going to importing here the logistic regressions. Okay, logistic regressions. And also from sklearn I'm going to importing here the svm. See why actually importing here the machine learning model as well, and how can we know that this is a regression problem? Because see these questions, our project name is called the predictions. Project name is called a prediction. It's not a classifications. It's not a classification. So that's why we decided that regression problem maybe happen. Okay. Then also, so let's say from sklearn dot tree, we can importing here the decision tree classifier. Well, and also from sklearn, okay, sklearn dot ensemble, I am gonna importing here the random forest classifier. Okay, and also from sklearn dot pre-processing, we are going to importing here the standard scalar. So why standard scalar? See, when your data point did not have any gap. Let's say I have one data point which is coming from 1 to 100. 1 to 100, let's say 1, 13, 14, 15, 16, like that. You're simply going to make this data point into one single range. It can be 0 to 1, it can be -1 to 1, so that your machine learning model can easily understand your data and try to check for the patterns. Okay, try to check for the find the pattern on that, so that it can do the prediction well. That's why a standard scalar, also called the standard scalar. And also from sklearn dot metrics. Okay, I am going to importing here the accuracy metrics, or you can say accuracy score, and also importing here the pkl, or you can use here another technique called joblib. So let's use this one and see that. Now it's loaded. You can see a static sign is gone and 1 is coming up. Now what I can do, I am simply going to load our data set. Let's say pd equal to df equal to pd dot read underscore csv, and inside there I'm giving my path of that. So my dataset name is called load underscore data dot csv. It is the same folder. Okay, so that's when our data set is loaded right now. You can see this one df.head. Okay, so you can see how many columns and the how many rows are available. You can see the row, how many rows are actually available, but you can see that how many columns are available. So if you want to show it more, you can check it by based on shape. So we have the 381 rows and 13 columns. Okay, so the last one, the last column is nothing but called the our target columns. Okay, that's a loan status, no and a yes. The user is granted for the loan or not approved, like that. So what I can do, we can also check in the tail of that. So let's say tail just mean taking the last some few data. You can also check that how can you actually do that. Now what I can do, we simply going to checking the information regarding our data set. Okay, let's explore in more. Let's say df dot info. Then you can see information regarding your data set. So you can see here with having some missing value, I guess. Okay, it is nothing but the objects. That's mean nothing but it is string. Then this is string, and it's integer and the float, and objects. Okay, that's mean we need to convert this categorical column. It's also called the categorical column into the numerical as well. Just think in that. Just remember this one. Yeah, we need to do that. Okay. Now let's try to move further and try to checking for the null value. Okay. So let's say handling, we can say handling missing value. I see here there's some missing value because see this is 381 and some value is missing. You can see some value are missing. Okay, so that's why I assume that yeah, it having some null value. So let's say is null dot sum. Okay, now you can see here it having some missing value. It's having some missing value. It having some missing value. It having some missing value. You can also check the percentage of that. Let's say how can you check that? df dot is null. And if you're taking the mean of that, and after that you need to using the 100, then you can get here the percentage of that. So it's 1.3% and 2.0%, 5.5%, 2.8%, and 7.8%. Cool. So now what I can do, we're simply going to drop the unnecessary column first. So loan ID is not important, so we can simply going to drop it out. So what I can do, we can simply using here df dot drop. Okay, we can simply drop it out. So we can drop the loan ID. Okay, we can drop the loan ID. That's it. It should be loan ID, and you need to giving the axis in which axis from the whole column. Just drop it. Okay, and if you want to check this out, let's say df.head, then you can check this one. That's loan ID is gone. Now what I can do, we simply going to remove here the nan value from our dataset. See, when you have the missing value, you can handle it in a different way. Otherwise, you can remove the nan value. You can remove the whole column. Okay, whole column. Okay, if you have more amount of missing value, you can also replace with the mode and the median. Mode and the median. So what is mode? What is mode actually? See, what is mode? Mode का मतलब क्या होता है? Mode मतलब which one is having the most frequency? Most frequency. And median is nothing but median is matlab mean. Okay, just not median, actually it's called the mean. Okay, mean means it's nothing but it's just taking all of the columns and we divide the number of columns. Okay, it's called the mean. And mode is most frequent number. Most frequent number is called the mode. Now we decide that which kind of tactic you're going to be using it here. We see that we have just a single number of just not so much, just a few amount of missing value. If you see that 5, 21, and 11 and 13, if you remove all of the row from that, so our data having some issue because we just having 380 columns, 380 rows, not column actually. That's mean our data should be reduced. So we need to taking some actions on that. How can we handle the missing value? So we can also do one thing. We can simply going to drop some column which one having the less number of missing value, and which one having the more number of missing value. We simply going to replace them. We simply going to replace them with the mean of the mode. In the mean of the mode. Just we're going to taking this out. So what I can do, the column it having the more number of missing value, we simply going to replace them with the mean of the mode. Okay, mean or the mode. Otherwise, we simply going to drop them if it having less number of missing value. So I see that it having some less number of missing value inside the vendor, and also have the dependent last number missing value, and also the loan amount term. And this one having the great number of the more number of missing value. So simply going to using here the two technique. It can be mean, it can be the mode. Okay. So now let's what I can do. We simply drop them. So let's say df, not actually df dot drop now, and inside our subset we simply going to giving here the vendor, and we have the dependent. So let's say dependents. Then what we have the loan amount. Loan amount term. Okay, simply to drop the NaN value from here. Now if you're checking the shape of that, then you can see that how many value is reduces. Okay, it having the 358. So we have the 381 minus 358. Oh, not 258, 358. So 23 value is removed. If I removing here just a more column on that, more data, let's say we have 30 and the 21. So let's say 30 minus 21. So see 30 and 21, it should be removed from here. If I remove this one, you can see just white. So you can adding this one, we can adding this one. Then after that we can give one bracket. Okay. No, sorry, not like that. The shape is right now this one. So if I simply going to add more on that, and that's mean, okay, not from that, 358 minus 13 minus 11. Okay, that's mean our data should be 317. Our data should be 317. That's mean it's बहुत सारे डेटा यहाँ से गायब हो जाएगा. बहुत सारे डेटा यहाँ से गायब हो जाएगा. So many columns are gone. Okay, I'm not going to actually waste the time on here. So let's take some shell. को समझ आ रहा होगा शायद. Okay, now what I can do is simply going to now checking that, let's say df dot if null dot sum. If it's really gone, it is really removed. Yeah, it's really removed here. Now I need to take care the self-employed and the credit history. Self-employed and the credit history, which are having the more amount of missing value. So how can you handle them? Let's check it out. So let's say self-employed, okay, self-employed dot unique. First check that how many value it have. Unique. So it have no and the yes value, and nans mean it's missing value. That's when you have two value and it's also the categorical. So we can take in the mean of that. If I take in the mean of that, it will give me error, because this is not the continuous value. This is not the continuous value. It is string. It's nothing but a string. So what I can do is simply going to take in the mode of that. Okay, mode of that is mean which one is most frequent. Which one is most frequent? So if I taking this one, let's say mode, then you can see it's coming no. It's coming no. That's mean we're replacing all of the value which one is missing with the no. With the no. So let's simply checking for the another one. So let's say copy this out and checking the same thing for the credit score. Credit score. Okay, and credit score it have the 1 and the nan and also the 0. Which one is a numerical number? Which one is a numerical number? If I taking the mean of that, it should be a fractional point. It should be a fractional point because it's 0.85. It should be one fractional point. So the fractional point is not available in our credit history. So what should you do now? To take in the mode of that as well. To take the mode as well. If we're simply going to actually replace this no to the 0 and is to the 1, same thing can be happen. Fractional point can be happen. Coming. So self point cannot be a fractional. It can be 0 or it can 1. It can be yes or it can be no. It not be yes no. Okay. मुझे लगता है हो सकता है, ऐसा नहीं होगा. Okay, not like that. Okay, so okay, fine. Now we got here one. So what I can do now, we can simply going to replace all of our data, the two data into the mode, from the mode. So what I can do is simply going to copy this one, this self-employed, and also the credit history, Okay, so what I can do is simply going to using here fill na, okay, dot fill na na means fill na, and the df of credit history with mode first one, first index, and also in place equal to true, so that it can place it into the same data frame. So let's copy and paste it here, and also this one. Now gone. Now if I try to check in this one is null dot sum, then you can see one thing. It don't have any missing value. It don't have any missing value. If I try to check in there, let's say df of you can check in here this type also, but yeah, you can also do like that. So all of the column is right now objects, 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 objects. We need to convert them into the numerical. We need to convert them into the numerical. So what you can do, let's try to checking that. So let's say first checking for the gender. So gender dot unique, unique, then you can see it having a male and the female, so you can convert them into the 1 and the 0. So let's checking for the dependent. Let's checking for the dependents dot unique. Oh my god, it having some problem. We got 1 3 plus value. We got 1 3 plus value, so we need to replace them. So let's copy this one and try to replace it. So we have the 3 plus, we need to replace it with the 4. Let's say 4, or you can give it a 3, and let's say in place equal to true. You can give it here 5 6 whatever else, because dependent means किसके ऊपर आप dependent हो. Okay, मैं तो पापा के ऊपर dependent हूँ ऐसा. Okay, 4. So if I try to checking it again, then you can see it having 1 0 2 4. You can make it 3 as well, it's up to you. Okay, so now what you can do, we're simply going to checking for the all of the things. There's like merit, you can checking for the merit. So df of, let's say, merit dot unique. Okay, unique, then you can see yes and no. You can actually using here df of like that. Okay, it will give me the error. You need to just taking here of the column per personally yes and no. Okay, now what I can do, we simply going to creating here one encoding dictionary. We simply going to creating here an encoding dictionary and try to encode it. So encoding dictionary. So let's say, but before that, let's try to checking here df info again. So df info, which one is actually to do that. So we have the gender. So let's try to first do it out. So we have the gender. So what we need to do, we have the 2 gender. One is called male, it should be the 1, and we have 1 female. Female, it should be the 0. Ladies first. Okay, then we have the merit. So merit, let's say yes or no. So let's say yes and no is applicable for me. Okay, merit as well as a single. Okay, then you have the dependents. Okay, it should be dependents, because dependents is also in the form of the objects, so you need to convert them into the numerical as well. So it can be the 0 to 0, 1 to 1, 2 to 2, and 4 to 4. See why this one? See this one, 1 0 2 4. Okay, then we have the another column called the education or education, whatever you say. Then we have the graduate. Okay, graduate, I can write it out, so that's why you can also checking here df.unique. Okay, and not graduate. So let's say not graduate. Okay, it should be the 0. And then what we have the self-employed. You can see the self-employed. Okay, let's say self underscore employed, and you can copy this one yes and no, yes and no, this one. And then what we have the property area, property underscore area, It should be the three things. It can be the rural area. Okay, rural. Let's get list type of thing. Then we have the urban and the semi-urban. Let's making it first. Semi urban. Let's making it 2 or 1, whatever else, or let's making the urban equal to 1 because I like the urban too much. So let's say इसको 1 पे रख दिया मैंने. It's up to you. You can choose 1 or 2. Then we have the loan status. Let's say loan, it having the status. Fine. Now let's have the y. Capital Y should be 1 and capital N should be the 0. Cool. Fine. Shift enter. Now we're simply going to replace it. Let's say df dot replace, and inside that we're simply going to passing here our encoding dictionary and in place equal to true. अब मजा देखो, मजा. So let's say df dot info. हो गया ना सब कुछ? int64, int64, int64. Categorical to numerical is done right now. This is a new technique. Okay, see, this is a new technique, shortcut technique as well. Now we simply going to divide our data set into dependent and the independent features. Okay, dependent and the independent features. You can also do the ED on here. It's up to you because I am not going to waste my time to doing the EDA. It's your part. You to do that. You can do the ED on here. You can do the ED on here. बहुत सारी ED ऐसे कर लिया. तुमको भी थोड़ा करना पड़ेगा. Okay. So let's say x equal to df dot drop. Why drop by? Why drop? Accept the loan status. We're simply going to taking all of them. Okay, status, we're taking all of them. So let's say from x is 1 and y should be the df of, you can also using the location df.lock as well for getting the location of each of the columns. So status bus ho gaya, x and y में divide हो चुका है. Now if I see the data set again, let's say df.head, say those are the column 1 0 0 like that. This is nothing but in the from the standardizations. Standard में है, normalized में है, लेकिन if I see this one, this 2 3 column, it's not in the form of standardizations. It's not in scale. You don't have any range between 0 and 1 or -1 to 1. So what you need to do, you need to apply here the standardizations or a standard scalar in these 4 columns. In this 4 column. So what I can do, we can say let's number of columns. So let's say number of columns, or you can say numerical columns. So we're simply going to paste it here first. Then after that, we're simply going to copy one of them and try to paste it here. Okay. Then we're simply going to copy this one. समझ आया ना? लोगों समझ के देता हूँ देसी भाषा में. देखो यहाँ पर मेरा जो डेटा सेट है ना, इसमें जो जेंडर मेरे डिपेंडेंट है ना, वो 0 एंड 1 का बेस ही है, इसका अंदर ही है. लेकिन जो एप्लीकेंट इनकम है, को एप्लीकेंट इनकम है, लोन अमाउंट है, लोन अमाउंट टर्म है, वो क्या है ना, वो थोड़ा इधर पतर है, नॉर्मलाइज नहीं है, 0 एवं 1 के रेंज में नहीं है, -1 से 1 का रेंज में नहीं है. तो क्या प्रॉब्लम होगा? आप जब मशीन लर्निंग मॉडल बिल्ड करने जाओगे ना, तब मशीन लर्निंग मॉडल बोलेगा मुझे क्या दे दिया तूने. हाँ, वो बोलेगा क्या दे दिया मुझे तूने. तो इसलिए मुझे क्या करना पड़ेगा, उसको थोड़ा रेंज में लेना आना पड़ेगा. तो इसलिए क्यों? क्योंकि हमारा जो मशीन लर्निंग मॉडल बना चुका है यहाँ पर लॉजिस्टिक रिग्रेशन एसबीएम डिसीजन ट्री, वो थोड़ा पैटर्न ढूंढता है ऐसा करके. तो इसलिए पैटर्न के लिए हमको क्या करना पड़ेगा, उसको नॉर्मलाइज करना पड़ेगा. इसलिए हमारे मशीन लर्निंग मॉडल इसको अच्छा तरह से प्रेडिक्ट कर सकते हैं. ओके, सो हिंदी तो गलत हो रहा है मेरा. ओके, सो लोड अमाउंट, दैन इसका बाद हो थोड़ा प्रॉब्लम है क्या पर लोड अमाउंट. ओके, या थोड़ा सा गलत ही कर दिया मैंने. नाउ इट्स फाइन, कूल. And loan amount and also loan amount term. So it will be loan amount term. So okay, that's why we're choosing these ones. This numerical column which are having some SSS zigzag hota hai na. So now what I can do is simply going to scale. Yeah, you actually using here the creating the object of the scalar, a standard scalar, not a scalar, right? A standard scalar. And after that, we're simply going to fit it out. So let's say scalar dot fit and also transform, because this is the training data as well. So what I can do is simply going to pass here x of numerical columns, and also need to copy this out in the same folder, the same variable, not folder actually. Okay, now our data is scaled. If I see that, if I see the x dot head, then you can see our data set is right now range between -1 to 1. You can see minus. Okay, now our machine learning model can easily understand it and try to take the pattern from that. Okay, just guess the pattern from that. Now it's so easy to creating our prediction model. Okay, prediction model. Now what I can do is simply going to define our models. So let's say models. Okay, define our models. So which kind of model I'm going to using it here? Let's say logistic regressions, then SBM dot SBC support vector classifier. Then we have the decision tree classifier, then we have the random forest classifier. Okay, random forest classifier, and also the gradient boosted. We okay, we don't actually import it, we need to also import it out. So here we go, we need to import it. So let's say the gradient boosting classifier. Okay, let's copy this out. You can also using the regression as well. Okay. अगर मैंने एक गलत चीज बोल दिया, देखो, yeah, this is a prediction model, this is a prediction, okay, this is a loan approval predictions, but it should be the loan approval classification. Why classification? Because the data set that I'm actually using it here is nothing but that loan is approved or not. Loan is approved or not. So that's why I basically actually importing here the regressions, because logistic regression is also help us to do the classifications. But I forget this out, okay? Because this is a classification problem. Okay, sorry for that. It's my mistake. Okay, so that's why importing here the classifier. Cool. Now what I can do, we simply going to use the shift enter. Okay, it's not defined because you need to also running this shell. Okay, it's running. Now if I simply going to run this out, so you have the models. Now you can see I actually make one shell empty. Why? Because we're simply going to writing here one validation functions, model validation function. Every model is going to pass it inside these functions, and these functions give me the accuracy as well as my cross validation score. So that's why I make it empty. So let's define here. Let's evaluate the score or evaluate the model. So let's say evaluate the model, which one taking one model. And now what I can do, we divide our data set into train, test, and split. Okay, and passing here x and y. Then we need to giving here my test size. Okay, थोड़ा speed करता हूँ मैं. Test size equal to 0.2. Then we have the random state so that it's not changing the state of that 42. And then we're making it x train and the x test and the y train and the y test. Okay, bas khatam. Then we're simply going to fit with our model. So let's say model dot fit, and inside that we're passing here our x train and the y train. Bus. Okay, then we're simply going to do the predictions. Let's say model dot predict inside our testing data. So let's say x test. So it should be our predictions. So let's say y predictions. Now we're simply going to pass our predictions inside our accuracy x score method, and inside that we need to giving here our seen data and the unseen data. So not unseen data, actual and the predicted data. Cool. So that's our accuracy. Okay, that's our accuracy. Then we're simply going to do the cross validations. So let's say cross validation S score is nothing but my model, and the x and the y and cb is nothing but the 5. It's nothing but my fault of that. See, it's meant it's actually taking the x and y and try to train, test, and split, and also it will try to uh, fold it with the fold data, fold with the whole data. Now we also can calculate the average cross validation score. So let's say average cross validation, okay, equal to, we can using here the np.mean, and we can simply going to passing here my cross validations. Okay, it's my cross validation score. So simply going to print it out, and I'm going to actually return here this average cross value. Why it is, I'll actually told you that why you're returning here the average cross value. I'll discuss this later on. Okay, why? Because it's needed in our hyperparameter tuning. So let's say model dot underscore underscore class underscore 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 name. So it will give you the model name, which one you're going to passing it here. Then what I can do is simply going to take in that, let's say accuracy in the form of here, let's say accuracy, and we can take in the point to f. Okay, point to f. Then we have the cross validation score. Let's cross val score. So inside that, what I can do is simply going to passing here our average cross bell. Okay, cross bell. So what I can do is simply going to making it out, okay, in the point to f, and after that we're simply going to return it here. So let's say average cross bell. Cool. So our function is ready. That's called the evaluate model. So now we can simply going to evaluate our model. So what I can do is simply going to take it here. Let's say model dot uh, underscore class underscore dot underscore name underscore, and we're simply going to evaluate our model here. So let's say evaluate. Okay, evaluate model, and inside that into passing here a model. So where we can get it from models. Let's say model in models, and then inside that we need to passing here our model. It is anonymous functions. Okay, you can using the lambda as well. So let's say model score. Okay, having some error, accuracy is not defined. Accuracy is not defined. Accuracy is not defined because थोड़ा mismatch हुआ है यहाँ पर. Now let's see. For the logistic regressions, we got 85%. For the random forest, 83. SBC, 85. Decision tree, 83. And gradient boosting, 86. One is missing. Anything missing? We have the logistic regressions. Okay, random forest is getting also 83%. Okay, cool. Decision tree, the random forest, and the gradient booster. Gradient booster taking here the 86%. Okay, cross validation score is low. It just having the 82% and 84% for the random forest classifier. Okay, so now let's try to tune our model. So what I can do, we simply going to define here a function called the tune model. So tune model, this one taking the model and as well as our param grid. So param grid का मतलब क्या है? If you're coming for my advanced projects, I also discuss about that. What is the parameters in our each of the machine learning model? You can do the hyperparameter, because when actually importing the logistic regressions or the SBC or decision tree, it having some default parameter. You can also change the parameter as well based on your data. You can do the parameter tuning. That's called the hyperparameter tuning. And for the hyperparameter tuning, we're going to using the random ICB. Okay, we're going to using the random ICB, and inside that we're passing my model and my param grid, which one I am going to discuss that, or which one I am going to uh, creating that. Okay, param grid. Okay, and 4 is nothing but, let's say 4 is nothing but 5, and number of iterations, let's give it here the 20, and verbose, let's say give it here throw, so that you can see that. And then random state is nothing but the 42. Random ICB. Now our tuner is ready. It's our tuner. Tuner is ready. Now based on the tuner, we're simply going to predict our model. So we can using a tuner dot fit, and inside it passing here x and y, and then we're simply going to print it out. We're simply going to print it out here, which one is the best score and which one having the best parameter. So that's the best score. Okay, it should be inside the f string. Okay, best score for, let's say model dot underscore class underscore dot underscore name underscore, right? And you can simply going to use it here, and the tuner, okay, not tuner dot best score. So let's say best score and underscore dot, we can giving here the point of that, how many point you're going to taking out. So let's say 0.2f, and we're going to copy this out, and we're going to paste it here, and best parameter. So let's best parameter for this one. So model and tuner dot best param. So let's best, it should be the params, cool, underscore, and then we simply return here our best tuner param. So let's say tuner dot best estimator. Which one is the our best estimator? Cool. So our tuner model is ready. Now what I can do is simply going to uh, specify here our parameters. Okay, parameters. So let's lock, and the regressions, that's been logic regressions, that's the grid equal to it having the parameter called the c. So I have to specify it inside the dictionary. So you can using here the np dot log space, let's say from -4 to 4 and 20, and then after that into giving him a solver. So there are so many solvers available in the logic regressions. You can go on the Google and search for that, how many solvers are available on that. It can be lib linear, it can be linear, so many of them. You can give any one of them here. So let's say I can give it here the lib linear. Then after that I am going to specify the SBC grid. So let's give it here the C, and then let's give it here some rest. Let's say 0.25, then 0. Let's say 50, 0.75, and that one. If you want to know more about it, you can also follow my advanced projects as well, which one is available in this Multiverse series as well, based on healthcare. I also discuss about the more details. This videos should be 2 hour long, which one I discuss more each and every projects. In each and every project, I discuss about the how can you do the hyperparameter tuning. I can do the hyperparameter tuning. Okay, so let's say kernel, and inside that I need to giving here a kernel, so it can be the linear kernel. Okay, now we need to do the same thing for the, let's choosing the RF, that's mean random forest classifier. So you can also do it for the decision tree and the boosting classifier. So it's your homework to do that. So the speed jar out, right? Okay, then after that what I can do is simply going to giving here our number of estimator. So estimator, थोड़ा slow जाओ क्या? Okay, थोड़ा slow जाता हूँ. Number of estimators, it can be np dot arrange. Okay, and inside that you can arrange some value from 10 to 100 with gap of 10 to 1000 and gap of 10. Slow down, mein. Then we have the max number of features, the max number of features. Okay, so it can be the R2, or it can be the log2, it can be a squared. So R2 is removed from the newer version of that. So into giving it the log2 base and also the squared. So squared is nothing but for the classification tags. Basically squared is used, and log2 is also used here. Now the which one is the best, it will taking it automatically using our randomized search CV. Fine. Then after that what you can do, you need to giving here the max depth. So max depth, so you can giving here some value. So let's say nan 3, 5, 10, okay, 20, and let's say 30. You can also give it some random value as well, but make sure that all the value should be in the same range, okay. Then we have the main sample split. Okay, should be main samples split. Split and C. So you can give it here, let's say 2, 5, 20, 50, 100. And also I'm going to giving here the min, okay, min samples lip. Okay, for the decision tree it is quite different because you're giving here the Gini and the entropy value. Okay, for the decision tree it different. So let's say 1, 2, 5, and the 10. For the ensemble technique is also same. Now let's run it out and try to use it inside our tune model functions. Let's say tune model, and inside that I am going to passing here, let's say first passing here our logic regression model, then also our param grid. So let's say logic regressions grid. So they give me the best log regressions. Let's say best log regressions. Fine. Now it will fitting to the model. So we got unsupported permanent string passed to dix. It's called the format. Anything else? Anything else? Anything else? Any problem on that? In this line, it having some problems. So here you can see that the model dot underscore class best parameter for, and the for the tuner we're using here the best score. Okay, best scores, and it should be the best params. Okay, best param is not to be having this one. uh, let's check it again. Tuner equal to randomize cb, and we're passing the model the param grid, and the cv is 5, the number of iteration is 20, verbose true, random is state 42, and best score is also be okay. Best score for model dot underscore class dot underscore name, and then we're using here the same thing. Okay, we don't have any problem. Okay, let's checking this one again. Yeah, now it's gone. So we got here 84% is the best score, and solver is nothing but the lib linear, and c is chosen here 1.62 this one. Okay, cool, it's the best parameter. Okay, now what we can do, we're simply going to do the same thing for the sbc. So let's say best sbc regression. So it's nothing but should be the tune model, and inside that you can using here sbm.sbc for model and the sbc grid. Okay, so our best parameter is called linear, and c is nothing but 0.25, and it's 84% accuracy on that. Cool. Now let's checking for our rf, I mean our random forest classifier. So let's say best rf equal to tune model, and inside that we passing here our random forest classifier, and after that we can passing here our rf grid. Okay, this one is rf grid. Fine. Now let's checking for that. It will fitting the 5-fold for the each 20 candidate, and totally fitting is nothing but the 100 fits. So it is taking time. Just mind, it can be 30 seconds. Okay, then after that what I can do, which one is best, we're simply going to choosing this one, and after that we're simply going to save it inside our job lib. So what I can do is simply going to job lib using the let's say job lib dot dump. We're simply going to dump it out and try to give it here one name of that. So let's say giving here one name, let's call loan status predictor. Okay, and dot age 5, like that. Or because this is nothing but a jobly one, so you don't need to give it the h5, because this is not a deep learning task. So you can just give it here loan status dot predictor dot pickle, like that. You can also give it a name like that. Okay, otherwise you can also leave it alone. Okay, it's up to you. So let's give it a pickle. You can also load it in the form of the pickle as well. Now inside that I have to giving here my model. So that's my final model. So that's my final model, and because it's running, so it's not actually I can choose that the random first by default, because I want to check that it's really working or not. So what I can do, you can using here let's say final model, and after that we can giving here this one, this best log or the best sbc or the best rf. Okay, let's waiting for a few seconds, then I come back again. While it's loading here, and best score is nothing but 84%. So you can choose any of them. We can choosing here the 84, this one, this one, this one. So let's choosing the which one is called the random forest. Let's using this one. That's the best RF, and try to running this one loan status predictor dot pickle file. And if I go on that, then you can see we have this one file loan status pickle dot pickle file. Okay, so now what I can do is simply going to first creating here one predictive system. Let's start building one predictive system, and after that we're simply going to convert them into the FastAPI. Okay, so let's try to building here one predictive system. Okay, prediction system or predictive system, which one? Okay, so let's try to do that. Well, so I am going to paste here some code, because I'm not going to actually waste the time, because it's already 1 hour gone. So so what I can do is simply going to taking one sample data and try to convert this dictionary in the form of the data frame, so that we can pass in this data inside our model as well. So you're using the pd.data frame, and inside that we're simply going to give it here one dictionary with having some value in the form of list. So you have the gender, merit, dependent educations, the self-employed, the applicant income, a co-applicant income, loan amount term, credit history, and the property area from the dataset. We're just taking some random value from our dataset and try to predict them that our model is really working or not. And then we're simply going to divide them, convert them into data frame. And after that, we're simply going to scale the value, which is nothing but the numerical columns. Because we have the numerical column. If we see that, those are the numerical column that we apply for the standard scalar, so that's why we choosing just those columns. Okay, just those columns, and try to draw the standard scalars with those columns. And after that, we're simply going to load our data, which one is saved. So load our model, which one is saved inside our directory, this one. Okay, and after that, we simply going to do the predictions, loaded model. And if the prediction is 0, prediction is 1, we simply say that loan is approved, otherwise loan is not approved. If I using this ones, and you can see here loan is approved. If I change some bill on here, so let's say this is nothing but, let's say 1000, and let's say this is nothing but, let's say 150. So let's say credit history, let's say you don't have any credit history, and try to predict it out, and you can see loan not approved. Okay, you can change the balance from here, loan is not approved. Now you can see our predictive system is also ready, and our model is also working very properly. Now what I can do, we simply going to convert convert this predictive system in the form of the FastAPI, So now we're simply going to go on the VS Code and try to implement here our first API. Okay, so let's go on that and try to check that how the first tip actually work. Well, so now we need to also do one more thing that actually missed here, because you need to also save here our scalar file, our vector file. Because how you try to do the predictions, you need to also have the model file and as well as our scalar file. So that's why I need to save it out, okay, in the same directory folder. Now I'm going to go on the VS Code. So that's our VS Code is ready. So now what I can do, I am simply going to go on here and try to creating here an app.py. Okay, so using this one, what I can do is simply going to creating here the FastAPI applications using FastAPI library. So for that, you need to also installing the FastAPI. So you need to open your command prompt and you need to type here the pip install the FastAPI. So this is already installed in my system, so that I don't need to actually install it again. And also you need to installing here one thing that's called EVCon, because using the EVCon you can actually run in this FastAPI applications, and after that we can test it out. Okay, pip install FastAPI and the EVCon. Cool. Now I'm simply going to close it out because I don't need to install it here. So now what I'm going to do, I'm simply going to importing here the FastAPI. So let's say from FastAPI, I'm going to importing here. I'm going to importing here the first. Okay, should be the first API, and then the HTTP exceptions. Okay, and also from Pydantics, I'm going to importing here the base model, because I'm going to actually using here the class method for creating the base model, and after that I'm going to pass in this base model inside my model as input, which one is coming from from the JSONs, because this is an API. Then also I'm going to importing here the job lib, and then I'm going to importing the pandas as PD. Let's say import pandas as PD. Cool. So our importing is done. Now I need to loading here our model file. So let's say model equal to joblib dot load, and inside that I need to giving here my model path. So it should be the loan. Okay, it's one loan status predictor dot pickle file. I can copy this out and I can simply go into paste it here dot pickle file, and as well as I need to importing here the scalar. So let's say a scalar is equal to joblib dot load, and inside that I need to giving here the vector dot pickle, as well as this scalar is applicable just on 4 numerical columns. So if I go on the code again and I need to copy this line from here, because I just need to apply this in the specific column. So that's why I need to copy this numerical column and I need to paste it here. Just paste it here. Cool. Now that's our numerical column and that's our scalar. Our standard scalars. Our vector file. Now what I can do, I am simply going to creating here one base model class. So let's say class. Let's say call loan approval Okay, and inside that I'm going to pass in here the base model, and inside that what I need to do, I need to give in here all of the feature names. So let's say it will take the gender, which one is nothing but the float, and then it will taking the merit, which one is also float. So gender merit is nothing but my features column. If I go on that, you can see gender, merit, dependent. You can see all of the things. Okay, I just need to write it down here in our base model. So let's try to take it out. Let's float. We don't need to give it to the comma. And then what we have the dependent. Okay, dependents, and it also be float. Okay, dependents, dependents. Okay, fine. Then what we have the education. So education is also in the form of float. And then what we have the self-employed is also float. Okay, then we have the applicant. Okay, applicant income is float. Float. Then what we have the co-applicant income, which one is also float, because we're simply going to taking all of the data in the form of the floating point number. Then you have the loan amount. So loan amount is also float. Then what we have the loan underscore amount. Okay, term is also float. Then you have the credit history. So let's say credit history is also in the form of the floating point number. The last one is called the property area. So let's say property area, okay, is also in the floating point number. Okay, so our base model is ready. You can also check it out. So gender, merit, dependent. Okay, you can copy that, and you can cross check all of the things. Okay, cross check. Just cross check gender, merit, dependence, educations, self-employed. You can see applicant income, co-applicant income. Okay, it's having some problems. Just need to copy this out, and I need to pass it here. So then we have the loan amount, loan amount, a loan amount, loan amount term. Then you have the credit history. So it having the credit history. You can see, yeah, fine. Then you have the property area. So we also have the property area. Cool. Okay, we can comment this out. Okay, it's not working like this way. Okay, fine. Now our base model is ready right now. Now what I can do is simply going to creating here our route. So let's say at the rate of app dot post, we simply going to create the post, but we not created the app yet. So we need to also creating the app here. So what you can do, we can say that let's say app equal to first API. So first API, we're creating the app right now. Now you can using this app and try to creating the method of that. So this is nothing but the post method. So inside this post method, you can giving here the predict functions. Let's call predict. Now our predict method will be called. How I actually call it in our API testing machine, just like the postman. Okay, you can using the postman for testing the API, right? Now what I can do, we simply going to creating here the async. Okay, async, and we can simply going to predict creating here and functions called the predict loan status, and inside that we're giving here our applications. So our application is nothing but my this one, loan approval. So it can be the application is nothing but the loan approval. Okay, loan approval. That's it. Okay, so our application is also ready. Why async? Because see, it will just taking this data, is taking the data in the from the JSONs from the users, and we need to just wait for a few seconds because data is coming. So that's why async. Okay, asynchronous functions. Now what I can do, we simply going to transform our data in the form of the data frame, and after that we're simply going to pass this data frame inside our scalar, I mean inside our vector, so that uh, it can it can actually convert this data into the form of the -1 to 1. Okay, So now what I can do is simply going to using the pd.data frame. So let's say data frame, and inside this data frame, we're to giving here the application dot in the form of the dictionary, because data is coming in the form of JSONs. Then we need to convert the data into the form of the data frame, right? So that's our input data. So that's our input data. Okay, and after that we're simply going to using here the scalar, because this scalar is nothing but my vectors. So I need to convert the specific columns data in the form of the scale. Okay, so what I can do, I need to using the transform, because this is the testing part, not the training part. If you are doing the training part, you need to using that scalar dot fit transforms. So it should be the transform. Okay, it should be the transform, and inside that I can giving here my input data, and I need to giving here this number of column, I mean the numerical columns. Then I need to copy the same thing. And I'm going to pass it here. Okay, same thing that actually creating here the predictive system. If I go on that, you can see here how I'm actually creating the predictive system. The prediction system, you can see here, we also convert them into from the scalars, the specific columns. We need to do the same thing here. So we do the transformation of the data. Now we can simply going to predict it out. So what I can do, we can using here model dot predict. Okay, predict, and inside that I can using here this input data. We can using the input data, and this is nothing but my results. That's nothing but my results. And after that, if the result of the first index, or 0th index is equal to 1, that means loan is approved. So we can return that. Loan is approved in the form of JSON. So let's loan status. Okay, loan status. Okay, so it should be the approved. So let's say approved. Otherwise loan status is not approved. So let's say else okay, else return the loan status. So loan status, okay, not approved. Okay, not approved. Let's say not approved. Well, now it's gone. It's not gone actually, it's now completed. Simple code, right? Okay, so now let's try to run it out. क्योंकि मच्छर बहुत काट रहे थे, इसलिए मैंने थोड़ा स्टॉप कर दिया. Let's run it here now. So let's say ubkern. Then we need to giving here our app name. So app.app. Then we're to giving here the reload, so that it can reload after saving each time. So app is nothing but my applications, and app is nothing but my file name. Okay, so let's reload it. I mean, let's run it, and you can see here ubkern is running in this link. Okay, this localhost link. So I just need to copy this out. And also one thing you can see, we're using the app.post. So post is nothing but the method. There are two types of method are available. One is called the get method, and another one is called the post method. So what I can go, I am going to open the postman. Using that, you can actually send the request to the API. So our request is nothing but the post method, and there are so many methods are available. You can see put, patch, delete, copy, so many things. I'm going to select here the post, and I'm going to patch it here. There's link, and after that I need to giving here my method called predict method. And now inside this body section, I need to select here the raw, and instead of the text, I need to select here the JSONs. Then after giving my data, so they're having some dummy data. I'm going to copy this out in the form of JSONs, and after that I'm going to pass it here. Okay, and just send the request on that. Now sending request, and you can see here it's called say not approved. Loan status not approved. So this data, the JSON data, is nothing but coming from our server. That's our server that you can see not approved. Now let's select here the another one. Let's copy this one, and I'm going to go on this postman, and I'm going to pass it here. Just pass it here and try to send the request again. And you can sending request, and you can see loan status is approved. This is how you can creating the postman API. Sorry, postman nahi, fast API. Okay, using Pythons. So this is how it actually work. You can change your value on here and try to send the request to that API, and it will give you the response. Okay, that's the response. You can see range preview, and you can also do the visualizations. Okay, pretty well. So that's it for today now. Hope you enjoyed this full tutorial, and I'll be back with the another tutorial. So till then, take care and bye bye.